Hi everyone, in this video I'm going to give an introduction to Numpy arrays. So I'll click into the reading about Numpy arrays, and how we're going to learn about Numpy arrays partly is going to be through this tutorial, which is in a Google Colab Python notebook. And so if you have not already, I would suggest actually going back and watching this Python Notebooks intro video, just to make sure that you're comfortable with that notebook. But if you've already done that, you can proceed with this video. So I'm going to go ahead and just click through to that tutorial. I'm going to open it in an incognito window so that I'm not automatically signed into my Google account. And I'm going to show, if you've already watched that intro to Python Notebooks video, you'll know that you're going to need to make a copy of this. And to do that, you're going to need to be signed in. And I have a Google account that I created just as an example for this class. So I will log into that. You can log into whatever Google account you want, as long as you have access to it. Let's see if I can get my password right. All right, so now let's see if we actually made a copy or if we just signed in. Oh, nope. We did not make a copy yet, so I will make that copy. And so now I have a copy of the NumPy tutorial where I am able to run code. So in this tutorial, we start off, we learn just a little bit about what NumPy is. NumPy is a Python library for creating and manipulating vectors and matrices. So the big thing with NumPy is it allows us to create arrays, which are similar to lists in Python, except they are much faster for computing numerical operations, and they must all contain the same data type. Whereas we've seen that lists can contain, I can make a list and it has a string in it, and then it has a float in it, and then it has a bool in it. NumPy arrays have to all be of the same data type, and that's part of what makes them so fast. So you can read about using this notebook here. I also, as I've said, encourage you to watch the video about Python notebooks. To use NumPy, you're going to need to import it. This is just the same as if you were working in the Python shell. So here I'm running this cell here, and once this cell has been run, I now have NumPy available to me, and I can start working through this reading. So the very most basic thing that I'm going to want to do with NumPy is to create an array. And so we see that if I use the command np.array, and then inside square brackets I put in whatever values I want, Python will return to me a one-dimensional array. So let me just go ahead and run this, and I can see that what I have is an array of these values. And you might wonder to yourself, hey, is this one-dimensional array a list? Because it sure looks like a list. But let's look at the type of this thing here, of this one-dimensional array variable. And here we'll see that, no, if it was a list, I would see class list, but I see class numpy.ndArray, which is telling me that it's a Numpy array. So that is the very most basic way to create one-dimensional arrays. Now, we said that Numpy arrays were useful for representing matrices, and so here we see a first way to create such a matrix. So the code that we see here creates a 3x2 matrix. I will go ahead and run this, and we can see what the output looks like. So just like we said, there are 3 rows in this matrix and 2 columns. And so we enter this as there are some outer brackets here, and then in the inner brackets we enter 1 row at a time. So if I wanted to add another row to this, let's say I want this next row to be -1, 12. So now I'm going to see another row down here with -1, 12, and let me run that. And indeed, I've added another row here. A quick way to create a Numpy array is to use a call such as the np.zeros function. So we can see in this cell, if I run it, I'm going to create a one-dimensional array of all zeros that has 10 items in it. Let me run this, and indeed, here we have 10 zeros. I could also make a one-dimensional array of ones, and let's say I want this to have 5 ones in it. And now if I print ones, I will have an array of all ones. And you might be asking yourself, what is the point of this? Why would I need to create an array of all zeros or an array of all ones? Well, one reason you might want to create these is that these arrays are not dynamically sized. So when we are, say, iterating through a file, we've been creating these accumulator variables that maybe add items to a list for each line in the file. But when we're working with arrays, the sort of trade-off to their speed is, one trade-off is that we can't add things to them. We need to initialize them to the size that they're going to be. So if we knew that we had 50 lines in a file and we wanted to create an array using data from the lines of that file, we'd need to first initialize a length 50 array, maybe using something like np.zeros of size 50, and then we would fill in each position one by one. Next, we learn about other ways that we can generate these arrays. You'll probably remember that we could use the range function regularly in Python for iterating. In Numpy, there's a similar command called np.arange, and that creates a Numpy array that starts with the first number we input and goes up to 1 less than the second number we input. So let's go ahead and run this cell and see what happens. And just as we would have hoped, np.arange generated for us an array that starts at 5 and goes all the way to 11, which is 1 less than 12. Another really useful thing when working with Numpy is the ability to generate random numbers. Using random numbers, you can simulate processes and get sort of empirical information about how often different outcomes occur once you've modeled a situation. So you'll actually be creating a simulation of a game of Yahtzee in today's lab. But for now, let's just see how can we create random numbers in Numpy. So the syntax here is np.random, and if we want random integers, we can use the randint function. So, and then we give a range between which our random numbers should be generated. And then we also say how big, what is the size of this array going to be? So how many entries will it have? And here we're saying 6. So what are we expecting this variable to hold? Well, it should be a NumPy array of integers between 50 and 100 of length 6. So let's go ahead and run that. And that's what we see. This has 6 items, 1, 2, 3, 4, 5, 6, and they're all between 50 and 100. Now, if we want floats instead of ints, we can call np.random.random, and again, pass in the number of the size that we want. So this should give us 6 values between 0 and 1, and indeed that is what we get. So one thing that you might notice is that if I exclude these brackets, I'm going to get, oh, okay, this actually surprised me. I did not think that was going to work. So in this case, it looks like we can actually exclude those brackets, but if we were to do something like try to create an array A, which is just going to be np, oops, I'm going to set the variable A to be np.array, and let's say I want this to be, again, it's going to have 6 elements in it, but I'm going to make it the elements 1, 2, 3, 4, 5, 6, and then I'm going to print this. So in this case, if I try to exclude these brackets, I get an error. And that's because when I create arrays using np.array, if I just want a one-dimensional array and I want to specify the values, I need to include these brackets. But it looks like when I'm calling np.random.random, I can just directly input the size since it's randomly creating those. All right, let's run that again. Okay. So another great thing we can do with NumPy arrays is directly use mathematical operations. So as you probably remember, oops. Okay. As you probably remember, let's say I make a list of 1, 2, and I make a second list of 2, 3, or yeah, 2, 3. I might hope to add these together, right? I want something like list 1 plus list 2 is whatever 1 plus 2 is, 3 plus whatever 2 plus 3 is, 5. So that would be adding them like they were, say, vectors. But if I try to actually run list 1 plus list 2, I don't get that result. So let me just print that. And we see, what did we do? Oh, we did list concatenation, which is a really useful thing to do, but just not what we wanted in this case. So the nice thing about working with NumPy arrays is that math actually works because they're built for doing numerical operations. And so this section we'll be working with those numerical operations. So let's say we already have this random floats between 0 and 1 variable, and we can do something like just add 2 to every entry. So I'm actually going to print random floats between 0 and 1, and then random floats between 2 and 3, and we can see that simply calling +2 on random floats between 0 and 1 adds 2 to every element. And this is called broadcasting. The fact that I was able to add 2 to every one of these elements. For this class, you don't need to worry too much about broadcasting, but I would say the big takeaway is that when you want to use NumPy arrays for mathematical operations, a lot of times there's actually a really slick way to do things. For example, let's say I wanted to multiply these by 2. I can also do that, and what this does is it multiplies every element here. And that's actually what we do in this next cell as well. And so other mathematical operations can also be performed pretty easily on NumPy arrays, and I would encourage you to consult the NumPy documentation, which I will point out later in this video, if you need to look anything up, or also just post in Slack. It's probably a nice way to do whatever it is that you're trying to do, and maybe the fastest way for you to get there is to just get help from me or one of your classmates. And next in this tutorial, we get to our first task, which is to create a simple data set consisting of one NumPy array called feature that will be a sequence of integers from 6 to 20, and a second NumPy array called label that will be a, again, 15 value NumPy array that is whatever, in each position, it should have whatever feature was times 3 plus 4. So for example, in the first position, since feature goes from 6 to 20, in the first position, label should be whatever 6 times 3 plus 4 is, and that's 22. So our task here is to write ourselves a NumPy array, first for feature, which is just a sequence of integers from 6 to 20. So maybe I'll first run this to demonstrate that we get a syntax error because Python doesn't know how to interpret feature equals question mark, which we could have predicted. But if I fill this in, I need to, then I will not get a syntax error anymore. So I need a NumPy array. So that's coming from the NumPy package. And then if I want a sequence of integers from 6 to 20, I can use the arange function. I put in where I want it to start. That will be 6. Where I want it to stop, that will be 21 in this case because we want to include 20. And let's go ahead and take a look at that. Oh, it looks like it won't run until we have no syntax errors, which makes sense. So I'm just going to go ahead and comment these out and run that. And it looks like my feature is correct. So now let me work on label. So if we recall, we can do mathematical operations on NumPy arrays pretty easily, maybe intuitively you'd even say. And so what do we need to do? We just want to multiply by 3 and add 4 to everything in feature. How can we do that? We can say 3 times feature plus 4. And because of broadcasting, this will actually add 4 to every item and multiply every item by 3. And we can double check our answer here. For 6, we were supposed to get 22, and it looks like we did. So it looks like we did this correctly. You can also see, we can see whether we did the same thing as the answer given here, and it does look like we did. They have some extra parentheses, but those are not necessary. And then we can double click to close that up. The next task is to add some noise in this data set. So it says, to make your data set a little more realistic, insert a little random noise into each element of the label array you already created. To be more precise, modify each value assigned to label by adding a different random floating point value between -2 and 2. And it tells us to create a noise array having the same dimension as label. So again, I'm just going to print out the second part of this so I can just work on the noise array. So I know that this needs to be some random numbers between -2 and 2. And I don't know at this point how to specify that I want my random numbers to be between -2 and 2. But I know that I can make random numbers between 0 and 1. So let me just start off by creating that array. So remember, we use np.random, and then we input the size. And for us, the size will be 15 because it's supposed to be the same length as our label array, which has length 15, because that's how many numbers there are between 6 and 20 inclusive. So let's just run that, and it looks like we're getting 15 numbers between 0 and 1, so that's good. But what can I do to this array to change it into random numbers between -2 and 2? Well, the first thing I can think about is I know how to do things like multiply and add, right? I can multiply these all by the same thing, and I can add the same thing to all of them. So let's say I multiply this by 4. Now I have numbers between 0 and 4. And what can I do with numbers between 0 and 4? Well, if I subtract 2 from all of them, then it will shift my range to be from 0 to 4 to be from -2 and 2. So let's go ahead and do that. And now I see that, what are these numbers? They are all between -2 and 2. And so that's a sort of clever way to create this set of random numbers between -2 and 2 using these mathematical operations. And now, what's my next step? My next step is to add this noise to the label array. And how do I add two arrays? Well, I can just use the addition operator. So I say label plus noise. And let's go ahead and run this. And now let's look back at what was my label originally, 22, 25, 28, etc. Well, here I can see that there's been some noise added here. And instead of 22, I have 20. Instead of 25, this is slightly more than 25, etc. And again, there is a solution here. So far, we have mainly been focusing on one-dimensional arrays, but part of the power of Numpy arrays is the fact that they can be multidimensional. And I think that the terminology for multidimensional arrays can be a little confusing, so I'll try to be as clear as possible. In Numpy, a 1D array, like the ones we've been using up here, can have as many values as we want in it. It's still a 1D array. We would then say that this has length 15. A 2D table, say a 4x5 table, we would then say it has 2 dimensions. We can also call these dimensions axes. And if, say, we had a 4x5 table, maybe I will go ahead and create one so we can look at it. If we have a 4x5 table here, we would say that this has 2 dimensions, and we would say the first dimension has length 4. There are 4 rows here, 1, 2, 3, 4, and each of those has 5 elements in it. And if we do something like ask what is the dimension of x using the .ndim attribute, we would see that this has 2 dimensions. And we have also been talking about the length, and the shape attribute can tell us those lengths. So if I say x.shape and print it out, I see that length 4 is in the first axis, or the first dimension has length 4, and the second axis has length 5. I'll also point out this syntax for array creation. So if I wanted to make a, say, 3-dimensional array, I would just add in another argument here, which is going to be the length in that dimension. So if I now want a 3D array, I add in the length that I want for that dimension, and now we can see that I basically have now 1, 2, 3, 4 copies of a 5x6 table. And this is a 3D array. And if we were to look at this shape here, we would see the same thing that we input above. Now, you probably remember that we use the index operator to index into and slice Python lists frequently. So for example, if I create a list called items and fill it with these things, we can use the indexing operator, say what is items at 3, and that will get us specific items in this list. So let's just try to predict what items at 3 will be. Well, this is the 0th index, the 1 index, the 2 index, and the 3 index. So we should get negative 12.2 when we print items at 3. And then we can slice by using the colon. And so here we should get whatever's between the first index, that's here, and the 3rd index, so that should just be dog at 9. So maybe we'll go ahead and run that, and we did get that. And then we can see that we can use the same syntax to index into or slice NumPy arrays. So in this line right here, we say np.arange of 10, and what does that do? Well, let's actually add some code here. So we no longer need to look at these anymore. We know what they do. Let's print np.arange of 10. That should give us a NumPy array between, actually I'll comment some things out. So what we should be seeing is a NumPy array that goes from 0 to 9 because we don't go to 10. Now, what happens if we call the exponentiation operator? Well, each one of these will be squared, right? This is saying square each element, and so let's take a look at that. So now we're printing A, and we see indeed 2 became 4, 3 became 9, etc. And then we can use the index operator. What is at position 9? Well, it's 81. And what is everything? What is the slice from 0 to 3? Well, it's just 0, 1, 4. Remember that we can leave off the 0 here. If we're just starting at the beginning of the array, we can just leave off that 0, and it's the same as including it. And then when we have multidimensional arrays, so for example, this multidim variable is a 3-dimensional array of random numbers between 0 and 1. We will print it out. We will look at what's at position 0, 0, 0, and then we'll look at what's at position 0. So this is the entire array here. This is what is at the 0, 0, 0 position. So that's that first thing here. What happens if we said 0, 0, 1? Well, I believe that's going to give us this item, but we'll have to see, and indeed it does. And then if I ask for just what is multidim at 0, so I'm only going down 1 level, I get this entire 2-dimensional array, right? That's what's happening down here. All right, so that is the content of the tutorial. And then the next thing for you to complete on your own is task 3, which just asks you a few more questions. And so this will be something for you to do on your own. However, I am going to go back to the reading so that we can look at the documentation. So actually, there might not be a link to the documentation in the reading. Indeed, there is not. However, there is a link in Lab 9. So in Lab 9, we have a link to the documentation. So I'm just going to go ahead and click on that. So this is the NumPy documentation. I would definitely recommend, if you are thinking about something you need to do, like maybe you need to sum everything in an array. Maybe we can see if there is a numpy.sum function. And then we can click into it and we can see information about how it works. So it looks like we can say numpy.sum and pass in an array. So just to demo this, I'm actually going to open idle because you can still, even though we did this tutorial in the Google Colab notebook, we can also, of course, use NumPy in our idle shell or in our Python source code. And so now I'm actually going to switch over to the Python shell. So I definitely need to import NumPy as np. And then I'm just going to show a little demo of using this numpy.sum function that we saw. So first I'm going to make an array. Let me call it A. I'm going to say that this is going to be an array of zeros that will be just one-dimensional, and there'll be 10 of them. So I can take a look at A like that, or I can print A. And now, let's say I want to sum it. I know that it should be 0, but let's just say I want to check. This is a good example to check the sum function because I know what the answer should be, right? So to use sum, I need to reference the package Numpy, which we have aliased as np. So if I try to do numpy.sum and pass in a, I'm going to get an error because we haven't defined numpy, right? We have np, which is an alias to numpy, but we don't have anything that's just called numpy. So I would need to do something. I would need to say np.sum of a, and here we expect 0, and we got 0. What if I had a multi-dimensional array? Let's say I make an array of 1s that's going to be a 3 by 6 table. So I'll take a look at A, and I see I have 3 rows, I have 6 columns, and if I take the sum of this, what do I expect? Well, I expect the sum to be over all elements of this, and so there should be 3 times 6 is 18 elements, each one having value 1. So I expect 18, and that is what I get. It looks like there's an axis argument, and if I want to know more about what this axis argument is, I can say, take a look at this should be the axis or axes along which the sum is performed. And so let's just take a look and see what happens if we did np.sum of a, and I said I only wanted axis 1. And here, what have we done? We have collapsed our two-dimensional array into a one-dimensional array where each element is the sum of all of these. Now, if I did np.sum of a 0, what do we expect? So now I'm going to collapse into an array of 6 elements, each of which is the sum of these columns. And let's take a look. And indeed, we got 6 elements, each of which is the sum of these columns. And so when you are looking up new array functionality, I definitely suggest exploring it in the shell or in one of these Colab notebooks, just to make sure that you know what's going on, because this is a whole new syntax, and maybe the behavior will be not what you think. And you can also always ask. So we have seen the documentation, we've seen NumPy both in our Python shell and in Google Colab notebooks, and so I hope you're ready to go out and work with NumPy on your own. Please ask if you have any questions. Thanks.